because these are all in symbols, so I give you numerical example, right? Numerical example. Let's say after 2 seconds, after 2 seconds, right? We look at this problem here, this example here. The object is projected at an angle with the horizontal with a velocity of 10 meter per second, right? Now, if you look at this velocity, it is not useful. It is not useful. So we don't look at it this way. We don't look at it this way. We don't look at it this way. 10 meter per second, it is not useful because it is at an angle. So this 10 meter per second, I resolve it into two components. Vertically, it is moving at 8 meter per second. Horizontally, it is moving at 6 meter per second. Okay, so I resolve it into two components. So we look at the horizontal component. Okay, now the horizontal component of the velocity is Vx, and it is the same as the initial horizontal component, that is 6 meter per second. Now this horizontal component is not affected by gravity. It is not affected by gravity, so it will maintain at 6 meter per second throughout the flight. Throughout the flight means throughout the journey lah. So it will be the same. So in every projectile problem, the horizontal component is always the same one. You don't have to worry how to manipulate with the horizontal component. The horizontal component is always the same because it is not affected by gravity. So now let's say after 2 seconds, how far in front it has traveled. So I find the horizontal displacement. So this horizontal displacement, you don't have to use this troublesome, this type of equation, because it is moving with constant velocity. All you need to do is here, here. All you need to do is you want to find the displacement, you use the velocity times time. That's all, velocity times time. So the horizontal component is very simple. Horizontal component of the velocity is always fixed. The horizontal distance, how much you travel in front, you just take the horizontal component multiply with time. So you take the horizontal component is 6 meter per second. So you use 6 meter per second, multiply with how much is the time, okay, after 2 seconds. So you multiply with 2 seconds, then you get 12 meters. So the object is 12 meters in front of you, horizontally 12 meters in front. But how high it is, we don't know yet. Okay or not? Because we managed the horizontal component and we found out the horizontal distance traveled in front is 12 meters. But it doesn't mean that the object is right in front of you. It may be somewhere up there, right? Up there. But we have not calculated the height yet. We only calculate the horizontal distance. Probably you call it the x coordinate. We have not calculated the y coordinate yet. So far, any question? No, no question. Then we move on to the vertical component. So in this problem, the initial vertical component is 8 meter per second. The initial one. So you throw the thing at an angle, it has a vertical component of 8 meter per second. Now this 8 meter per second is subjected to the gravitational pull. So as the object leave your hand, the vertical component will slow down. Even you throw it up, the vertical component will slow down. The horizontal component will not slow down. So we calculate the slowing down by using this equation. V equals to V naught minus GT. V equals to V naught minus GT. So I substitute the initial velocity initial horizontal component with 8 meter per second. Then this is subjected to negative 9.8, and after 2 seconds, what happened? Okay, so what happened is the answer is negative 11.6 meter per second. That means after 2 seconds, it is no longer moving up, it is coming down, right? That's why we have this negative 11.6. So probably it has exceeded the maximum point already. It is on the downward journey. That's why we have negative 11 here. Negative 11 is referring to the vertical component of the velocity, negative 11.6. The horizontal component is still 6 meter per second. Horizontal component still 6 meter per second, but the vertical component, are you looking at this diagram here? Are you looking at this diagram here?
Yeah. My
Yes.
mom came into my room.
So
Sorry. Yeah.
the vertical component is pointing downwards, and we have calculated to be 11.6. The horizontal component is still 6 meter per second. Okay. So now we have settled with the velocity after 2 seconds. I want to know what is the distance covered after 2 seconds. So after 2 seconds, we use this formula. Initial velocity, sorry, final velocity is the initial velocity minus half gt squared. Okay, so the initial velocity is 8, the time is 2, acceleration due to gravity multiplied by half is 4.9, and the time is 2 seconds squared. And evaluating this number, it turns out to be negative 3.6. Now, negative 3.6 means the vertical distance is below the horizontal level. It means that this is the horizontal level. This negative 3.6 means the object has gone below. The horizontal distance is 12 meters. That means from here until here, 12 meters. Then you go down some more, 3.6 meter. And that is the position of the projectile after 2 seconds, right? So from the numbers, we can interpret the position of the projectile and the velocity of the projectile. But both of them in their component form, okay, in the component form, in the x component and the y component. So far, any question? Oh, no. So what we have done, velocity broken down into two components, or we don't say broken down. As I've said earlier, we resolve, RESOLVE. We resolve it into two components, vertical and horizontal. So we calculate both the vertical and horizontal velocity, the vertical and horizontal displacement. How to do it? Using these four equations. Okay, move on.